Welcome folks. In this video we are going to look at the type of bonding that is found in a compound called beryllium fluoride. Now the concept that we are going to use to answer this question can be used to answer an ionic compound. So the question reads: beryllium burns in fluorine to form a white solid, beryllium fluoride. Then question A, name the type of bonding in beryllium fluoride. So from this compound, the first element that we have is beryllium. So we need to identify if this beryllium is a metal or non-metal. So beryllium has the chemical symbol of Be with mass number of 9, then the atomic number of 4. Then for fluorine, has the chemical formula capital letter F, the mass number of 19, then the atomic number of 9. So from the atomic numbers of each element, we can make the electronic configuration. So for this one, the first shell will occupy 2 electrons. So if we subtract 2 from 4, then we are able to see that the outermost shell of beryllium will contain 2 electrons. Therefore, beryllium is in group 2 and it is a metal. Then if we move on to fluorine, fluorine has the atomic number of 9. So the first shell, 2 electrons. If we subtract 2 from 9, the outermost shell is 7. Then this is in group 7, so it is a non-metal. So to simplify our question is that we are dealing with a bond or bonding that is taking place in a chemical compound comprises the metal and the non-metal. So for question A, name the type of bonding in beryllium fluoride. So this is an ionic bonding. Then the bond in between the 2 ions is ionic bond. Then the compound is ionic compound. Now we move on to question B. In the space below, draw a dot and cross diagram to show the bonding in beryllium fluoride. Show all the electrons. So first, let's draw the electronic structure for beryllium. So we are going to have 2 shells. And from the electron configuration, the first shell will have 2 electrons. Then the second shell will have also 2 electrons. So for beryllium to become stable, it needs to lose 2 electrons. Now let's draw 1 atom of fluorine. So we are going to have also 2 shells. Now for the first shell, we put 2 electrons. Then in the outermost shell, we are going to put 7 electrons. Now for the second shell to be filled, it needs 8 electrons. So for fluorine, 1 atom of fluorine is only lacking 1 electron. So this 1 electron must be transferred on this one. So now we can see that 1 atom of fluorine cannot receive the 2 electrons that are coming from the beryllium. So we need to have another atom of fluorine. So this is what happens if the number of electrons given does not equal to the number of electrons acquired by 1 atom of a non-metal. So this electron will move onto this one. That's why if we were to draw, if you were to write the chemical formula of beryllium fluoride, it can be written like this. Beryllium has a valence of 2. Fluorine has a valence of 1. So if we swap the numbers, beryllium fluoride will have a 2 here. So this is what it means, 2. So 2 atoms of fluorine to receive the 2 electrons coming from the beryllium. Then we can now finalize our answer. So I'm just going to write 1 shell. I'm going to ignore the outermost shell since the 2 electrons are given out. So let me use the cross. Then here we are going to have the other two atoms of fluorine. But remember, the charges must balance. So this one is now electrically stable. Even this one is now filled. So this is our structure. Now to show the charges, 2 electrons were given from beryllium, so we put +2. Then each atom of fluorine received 1 electron. So the total number of electrons that were received were 2, so we put -2. So we need to make sure that these two numbers must be equal to each other. So that is our point here. Then if we look at question C, suggests N2 physical properties of compounds that have similar bonding as beryllium fluoride. This question is same as the 1 to 2 physical properties of an ionic compound. So the first one, it conducts electricity. So electricity when in molten state. Molten state we are looking at when it is in ions, it is dissolved in water. Then the second one, it has high boiling and melting point. So the boiling and melting point of ionic compounds are so high compared to that of covalent compound. So this is how we can apply the concept of ionic bonding. And remember, the concept that we've used to draw our ionic compound can be used to draw any ionic compound. So it's not only for beryllium fluoride. So that's it for this video. Thanks for watching.